Hi, I am Dr. Jegluri, Associate Professor of Physics, Institute of Aeronautical Engineering. Today, we wish to talk about the numerical problems on magnetic materials. So, let me solve the numerical problems on magnetic materials. So, first one, calculate magnetization and magnetic flux density if magnetic field intensity is 250 amperes per meter and relative permeability is 15. So, in this problem, the given data is H, that is magnetic field intensity, is equal to 250 amperes per meter, and then relative permeability 15. But we need to calculate the magnetization and then magnetic flux density. So let me write the data which has been given in the problem. Magnetic field intensity H is equal to 250 amperes per meter. Then relative permeability mu r is equal to 50. We know that mu naught is equal to 4 pi into 10 power minus 7 Henry per meter, which is a permeability of free space. So mu naught is equals to, that is mu naught is equal to 4 pi into 10 power minus 7 Henry per meter. So susceptibility chi is equals to mu r minus 1. This is susceptibility. Chi is equals to mu r minus 1. So we know that mu r 15 minus 1 is equals to 14. So susceptibility is equals to 14. Let's see what we have to calculate. So we have to calculate magnetization, M, and then magnetic flux density. So which is denoted with B. So these two we have to find. So magnetic flux density B is equals to mu H. As we know that mu is equals to mu or mu naught. So substituting here, B is equals to mu or mu naught to H. So substituting the values of mu r and mu naught. So mu r we have 15, which is given in the problem, and then mu naught is equals to 4 pi into 10 power minus 7 Henry per meter. Then the magnetic field intensity H is equals to 250 amperes per meter. So multiplying all these values, we'll get 47.12 into 10 power minus 4 Tesla. This is the value of magnetic field flux density, magnetic flux density, capital V. And we need to calculate the magnetization value also. So we have the formula, magnetization M is equals to chi H. So chi is 14, which we calculated through the susceptibility formula mu r minus 1, that is equals to 14. So 14 into magnetic field intensity 250, it is equals to 3500 ampere per meter. So this is the magnetization value. So capital M is equals to 3500 amperes per meter. Next problem. Find relative permeability if magnetic field intensity is equals to 220 ampere per meter and magnetization value M is equals to 3300 ampere per meter. So the data, magnetic field intensity, H is equals to 220 amperes per meter, and magnetization M is equals to 3300 ampere per meter. As we know, the formula for susceptibility chi is equals to M by H. So we know M value and H value. Magnetization divided by magnetic field intensity. So substituting 3300 divided by 220 will get 50. So susceptibility chi is equals to 50 and relative permeability. So to calculate the relative permeability, so we need susceptibility value. That's why first we calculated the susceptibility and we got susceptibility value chi is equals to 50. Now permeability of the material, relative permeability, mu r is equals to 1 plus chi. So it is equals to 1 plus 15, it is equals to 16. So mu r is equals to 16. Next problem. The magnetic susceptibility of aluminium is 2.3 into 10 power minus 5. Find its permeability and then relative permeability. So in the problem, magnetic susceptibility has been given, but we need to find permeability and then relative permeability. So let's write the given data. So the susceptibility chi is equals to 2.3 into 10 power minus 5. So the formula for relative permeability, mu r is equals to 1 plus chi. So chi value has given. So it is equals to 1 plus 2.3 into 10 power minus 5. So calculating this will get 1.000023. Then To calculate permeability, mu is equals to mu naught into mu r. So it is equals to, we know that mu naught value is 4 pi into 10 power minus 7 Henry per meter. So pi value is 3.14. So 4 into 3.14 into 10 power minus 7. So that here we'll get 4 into 3.14 10 power minus 7 into 1.000023. So calculating this, we'll have 12.566 into 10 power minus 7 Henry per meter. This is the value of permeability. Next, fourth problem. If a magnetic field strength 300 ampere per meter produces a magnetization of 4200 ampere per meter in a ferromagnetic material, then find the relative permeability of the material. So we need to find here relative permeability mu r. So let's write the given data. So magnetic field strength H is equals to 300 ampere per meter. Then magnetization M is equals to 4200 ampere per meter. So to calculate the relative permeability, we should know the susceptibility value. So susceptibility chi is equals to M by H. So we have the data of values of M and H. So it is easy to calculate the susceptibility. So the susceptibility formula chi is equals to M by H. So substituting the values of M and H, 4200 divided by 300 is equal to 14. So this is the value of susceptibility. Now let's substitute in the formula of relative permeability. So the relative permeability mu r is equals to 1 plus chi, it is equals to 1 plus 14. 1 plus 14 is equals to 50. So 1 plus 14 is equals to 50. This is the value of relative permeability which is asked by the questioner. Next, a paramagnetic material. A paramagnetic material has a magnetic field intensity 10 power 4 ampere per meter. If the susceptibility of the material at room temperature is 3.7 into 10 power minus 3, then calculate the magnetization and magnetic flux density of the material. So the given data, magnetic field intensity H is equals to 10 power 4 ampere meter, and the susceptibility of the material at room temperature chi is equals to 3.7 into 10 power minus 3. Then have to find magnetization M and then magnetic flux density. So the formula for magnetization M is chi into H. So chi is equals to 3.7 into 10 power minus 3, and also we have H value. So substituting chi and H, it is equals to 3.7 into 10 power minus 3 into 10 power 4. So the magnetization value becomes 37 ampere per meter. Then coming to the magnetic flux density of the material, B is equals to mu naught into 1 plus chi into H. So substituting the values of mu naught, as we know that mu naught is equals to 4 pi into 10 power minus 7 Henry per meter, and chi as given in the problem and H also be there. So 4 pi into 10 power minus 7. So 1 plus chi value. So this P is equals to mu naught into 1 plus chi into H. So 4 pi into 10 power minus 7 into 1 plus chi value is 3.7 into 10 power minus 3 into 10 power 4. So it is equals to 4 pi into 10 power minus 7 into 1.0037 into 10 power 4. So finally, after calculating, we'll get the value 0.0126 Weber per meter square. So this is the magnetic flux density of the material's value. Then we shall go for another problem. A magnetic material has a magnetization of 3300 ampere per meter and flux density of 0.0044 Weber per meter square. So calculate magnetizing force and the relative permeability of the material. So the given data is magnetization M is equals to 3300 ampere per meter, flux density, magnetic flux density of the material B is equals to 0.0044 Weber per meter square, and we need to calculate it magnetizing force H and then relative permeability mu r. So the formula for magnetic flux density B is equals to mu naught into H plus M. So we need to calculate H. We are taking the formula which is related to magnetic flux density. So because the magnetic flux density value has been given, so that we took this formula B is equals to mu naught into H plus M. So from this we can calculate the H value. So from this formula H is equals to B by mu naught minus M. So B is equals to mu naught H plus M. So we need B is equals to B by mu naught is equals to H plus M. So from this B by mu naught minus M is equals to H. So H, magnetizing force, is equals to B by mu naught minus M. So here we know mu naught value. So the mu naught value is equals to 4 pi into 10 power minus 7 Henry per meter. And we know that. So 0.0044 divided by 4 pi into 10 power minus 7 minus 3300 ampere per meter. So that continuation I am writing here. So it is equals to H is equals to 0.0044 divided by 4 into 3.14 to 10 power minus 7 minus 3300. So 44 into 10 power 4 into 10 power 7 divided by 4 into 3.14 minus 3300. So this value becomes H is equals to 203 ampere per meter. So 0.0044 divided by 4 into 3.14 into 10 power minus 7 minus 3300. So by calculating this value, we'll get magnetizing force H is equals to 203 ampere per meter. Now we need to calculate the relative permeability. Mu R is equals to M by H plus 1. So mu R is equals to M is 3300, H is 203, which we recently calculated. So divided by 203 plus 1. So we'll get 17.256. So that is, we'll get 16.256, 1 and so on, this value. So when calculating 3300 by 203, we'll get 16.2561 and so on. So that 1. So plus 1 will have 17. So 16.2561 plus 1 will get 17.256, which is the relative permeability asked in the problem. So H is 203 ampere per meter. Mu R is equals to 17.256. Next problem. A circular loop of copper having a diameter of 10 centimeters carries a current of 500 milliamps. Then calculate the magnetic moment associated with the loop. So we need to calculate the magnetic moment mu. So let's write the given data. Diameter of the circular loop, D is equals to 10 centimeters. So D in the sense of radius, D is equals to 2R, that is equals to 10 centimeters. So converting into meters, 0.1 meter. Then radius of the circular loop, R is equals to D by 2. So 10 centimeters divided by 2, 5 centimeters. So converting into meters, 0.05 meters. Now current passing in the circular loop, I is equals to 0.5 amperes. 0.5 amperes. So magnetic moment mu is equals to A into I. So A is the area of the loop and I is the current. So magnetic moment mu is equals to area of the loop, which is a circular loop, so that pi r square into current I. So the value of pi is 3.14. So 3.14 into the radius is 0.05 meters. So 0.05 whole square into I is equals to 0.5 amperes. So here in the problem, the mentioned in milliamps, current is mentioned in milliamps. So converting into amps, I becomes 0.5 amps. So that is I is equals to 500 milliamps. So that is equals to 500 into 10 power minus 3 amperes. So that 0.5 amps. So that's why we have written here I is equals to 0.5 amperes. So mu is equals to pi r square I, substituting the values and then calculating, the magnetic moment becomes 3.93 into 10 power minus 3 ampere meter square. Next one, a permanent magnetic material has 10 power 28 atoms per meter cube. Its susceptibility at the temperature 350 degree Kelvin is 2.8 into 10 power minus 4. Then calculate the susceptibility at the temperature 300 degree Kelvin. So let's write the given data. So number of atoms in the magnetic material, capital M is equals to 10 power 28 atoms per meter cube. Susceptibility at the temperature 350 degree Kelvin is 2.8 into 10 power minus 4, which is denoted with Chi1. Then temperature T1 is equals to 350 degree Kelvin. Temperature T2 is 300 degree Kelvin. So the susceptibility at 300 degree Kelvin we need to calculate. So Chi2 is equals to question marks. This one we need to calculate. So the formula which we are using in this is susceptibility Chi is equals to C by T. So C is equals to Chi T. So when taking susceptibility at two temperatures, so that Chi1 T1 is equals to Chi2 T2. So from this, Chi2 is equals to Chi1 T1 by T2. So substituting the values, Chi1 is 2.8 into 10 power minus 4 at temperature. T1 is equals to 350. So 2.8 into 10 power minus 4 into 350 divided by 300. So it is equals to susceptibility at 300 degree Kelvin is equals to 3.267 into 10 power minus 4. So this is the susceptibility value at the temperature temperature 300 degree Kelvin. Chi2 is equals to 3.267 into 10 power minus 4. Next problem. When a magnetic material is subjected to a magnetic field of intensity 250 ampere per meter, its relative permeability is 15, then calculate magnetization and then magnetic flux density. So given data, intensity of magnetic field H is equals to 250 ampere per meter. Relative permeability mu r is equals to 50. So we need to calculate magnetization capital M and magnetic flux density capital B. So formula we are using to calculate magnetization, M is equals to H into mu r minus 1. So 250 into 15 minus 1. So it is equal to 3500 ampere per meter. Magnetic flux density B is equals to mu naught into H plus M. So mu naught is equals to 4 pi into 10 power minus 7 into 250 plus 3500. So it is equals to 4.71 into 10 power minus 3 Weber per meter square. This is the value of B, which is magnetic flux density. Next problem. Calculate magnetic moment per unit volume and flux density of a magnetic material placed in a magnetic field of intensity 1000 ampere per meter. So the magnetic susceptibility is minus 0.42 into 10 power minus 3. So the given data is intensity of magnetic field H, that is the magnetic field intensity. Magnetic field intensity H is equals to 1000 ampere per meter. Magnetic susceptibility chi is equals to minus 0.42 into 10 power minus 3. Now we need to calculate magnetic moment per unit volume or magnetization. So the formula for magnetization, M is equals to chi into H. So substituting the value of chi and H, it is equals to minus 0.42 into 10 power minus 3 into 1000. So it becomes minus 0.42 ampere per meter. This is the value of magnetization. Then for magnetic flux density, B is equals to mu naught H plus M. So it is equals to 4 pi into 10 power minus 7 into H plus M is 1000 plus minus 0.42. So that 4 into 3.14 in 10 power minus 7 into 1000 minus 0.42. So it is equals to 1.257 into 10 power minus 3 Weber per meter square. So this is the problems which is related to the magnetic materials. So the references related to the topic: Engineering Physics by K. Tyagarajan, Tata McGraw Publications, and your textbook of Engineering Physics, M.N. Avadhanulu, P.G. Kshetrasagar, S. Chand and Company. Next one, Engineering Physics by Dr. M. Armugam, Anuradha Publications, Chennai. Then Engineering Physics, P.K. Palanisamy, 4th edition, SciTech Publications, Chennai. So these are the references referred for this topic, that is solving the problems in magnetic materials. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.